Now, I want to talk CV. Okay. This is important. Okay, that's a typical CV capacitance versus voltage, right? Inversion, depletion, and accumulation, all three regions. Now, there's a problem with any CV measurement, and that is that, remember what I said earlier, everything's got capacitance, right? So we have to consider that. So this fixture has capacitance, these cables have capacitance. Anytime you have a switch, capacitance, right? There's capacitance in everything. I don't want that in my measurement. So I've got to get that out. There's a way to do that. There's a way to compensate out. It's very important. You've got to compensate out the capacitance. Now, there's a couple different ways to measure capacitance. I'll show you on here. The way they used to do it in the past, the old days. Look at this. Look what I've done here. It's a 4-terminal device, but I've only got 2. I've shorted the gate, not the gate, the drain, the source, and the bulk together.
The source, the drain,
and the bulk, all shorted together. Because what you care about is gate capacitance, right? Because you want a device that can switch fast, so you want low capacitance. But there's parasitic capacitances between every 2 pins on a device. It's physics, right? So by shorting out those 3 pins, I've eliminated those capacitors. Okay, they're gone. They're shorted. I don't care about those leads anyway. All I care about is the gate and the bulk, basically, and the bulk is tied to the drain and the source. So I've shorted out those parasitic capacitors. Now, that's one way to do it. If you don't have this, it's the only way to do it. With this, I don't have to worry about that because I can short those pins with this. So here's what I got to do. I got to go. First of all, I got to configure that guy. So I need another CV configure. So I'm just going to grab this guy. I'm going to copy it, and I'm going to put it right before my CV MOSFET. I want to paste it. Oh, I want to put it before it. So I'll put it there. Come on, move. Okay. So now I gotta set this up differently now because I want to set it up for CV. So we got it for smooth. We don't want it for smooth. We want it for CV. So what we got is our gate is smooth 3. So we want to set up SMU 3 to the CV high. So we want to put the high side of the CV meter on the gate, right? We want to put the low side of the CV meter on the bulk, which we're not connected to. But okay, so let's put it on the source or the drain. It doesn't matter. So SMU 1. So let's put this to CV low. Now we said with that other device, I shorted the gate, the drain, and the bulk. So here's all I got to do.
That went to CV high. By
Oh,
the way.
that's got to go to CV low.
Yeah.
So this goes to CV low. So all I got to do is make this CV low, and this doesn't matter because it's not connected. But we don't need it. But if we had another cable, yeah, we could do that. So now we're shorted those 2 pins, right? So now we've eliminated that parasitic capacitor between those pins. I didn't eliminate the one between the bulk though because I don't have it connected. But it doesn't matter. We don't care for this test. Okay, so now that makes sense, right? But now I got to run this so that now that'll change. See? CV low, CV high, and open. Okay? Now there's something else I got to do. I got to go compensate for all the capacitance in the system. So what I do is I go to Tools. There's right here. There's a CVU connection compensation. Now, there's 4 different things you can compensate on a CV meter. The first one is the cable length. That's the red cables. They're 1.5 meters long, so you don't have to touch that. You leave it alone. As long as you're just using our cables, it's good. Now those cables have to be matched, right? They have to be the same length, the same manufacturer, same brands. Everything's got to be identical on those cables because there's a phase component of the CV meter that if the signals arrive at the high and the low at different times, it could throw off the bridge, blah, blah, blah. Because it's an AC measurement. So you want to make sure you just use those cables, don't use nothing else. You never have to touch that. Then there's open compensation, there's short compensation, and there's load compensation. Forget about load compensation, you never need to do it. That's for like 50 ohm stuff, 50 ohm transmission line stuff. You're never going to do that. Don't worry about that. Because then you got to have a load. You got to have a 50 ohm load you got to put on there. You don't have to worry about it. Open compensation is the most important for you guys, okay? Because you need to do open compensation when you're measuring small capacitances, which is what you'll be doing, right? You're going to measure low capacitances. So low parasitic capacitances in parallel are going to matter to you, right? So you need to get rid of those. The short compensation is for large capacitances. So unless you're measuring large capacitances, bigger than nanofarads, you probably don't have to even worry about that. Don't even do it. All you really need to do is the open compensation. Okay? So that's what we'll do. So I'm going to say, okay, so what I got to do is I got to have everything cabled up. So if you got a probe station, all your probes got to be all set up. Your probes got to be at your device, and then you lift them, right? Because you don't want to measure the device. You're doing compensation. So here's what I'm going to do. I'm going to pull that device out, and I'm going to run this test. I'm going to say compensate. And then what it's going to do is it's going to run through
On the probe station, you said you just don't connect it and then
you don't put the device, so you drop your chuck,
Okay.
right? So that all the cabling is there,
Yes.
your fixturing, cabling, everything's there, but the device,
Right.
right? Because that's what you're trying to get out. You're trying to get all that cabling and all that capacitance gone.
Right.
Did that run? I should have showed you that it's running. Oh, I didn't do it right. I don't think. Wait, hold on. Connection compensation. Here, I gotta say measure open. That's what I gotta do. I said okay. Okay, so see, it says lift probes or remove device. And this test could take a while because it's got to go through you can see it, it's going to go through every frequency and every range, and it's measuring a complex impedance to calculate that capacitance, okay? And now what it's going to do is it's going to store that data on the CV card. So once you do this, you're good. You don't have to do it every time, unless you change something, different cables, whatever, right? As long as you're using the same setup, you never have to do this more than once. I would still do it once in a while just to make sure everything's good. So you let that run, it stores those values on the card, but then you're not done.
Yeah. But we may have to do that when we connect this to the probe station, right?
Yeah, yes, you will have to do it,
Then,
yes.
yeah,
Yes.
because they have a different.
Correct. Correct, but you'll only have to do it once. Okay, so that's done. But you're not done. Okay, so CV compensation is a two-step process. You got to run the compensation, and you got to enable the compensation. Because just because I ran it, it just means it put all those values on the card. Doesn't mean it's using them. So now let me show you what happens. Now I'm going to put my device back. My eyes don't work so good anymore. Okay, so the device is back in. We lost Manu. Okay, so now I'm configured. My CVU is configured, and I want to run this CV MOSFET test. Okay. Now, what you're going to see here is if I go to, that's like configure. This is my test. If I go to terminal settings, here's where I got to turn it on. So I did open compensation, so I got to select that for it to use it. So now it's going to subtract that capacitance that it found at all those frequencies from what it finds during this test. But let's not do it. Let's leave that off for now. So let's run this guy. Go to analyze. Let's run this guy. Let's see what happens.
So what are the settings used for the?
It was just the
It's
default.
the default. Something doesn't look right though. Something's not right. What's not right here? Something is not right. Let's go back. We got. Oh wait, now it's measuring. Now it's making sense. What's going on there?
Huh. What did you do?
I don't know. Now it's working. Okay. Okay, but now let me show you something here. That finish. We get rid of this.
That this was not perfectly.
Yeah, I think this was loose. I think is what it was. I tightened it. But okay, so I didn't add the compensation. So this is a bogus measurement. And I can show you that because it's probably going to have more capacitance than it really is. And by adding the compensation now, I can take that out. So I go over here and I'll go eliminate the open compensation and watch what happens. And I'll run this again. And you're going to get
What is the
something.
open compensation? Eliminate the open compensation.
No, I added the open compensation. I added it.
Oh,
I first ran it without the compensation, so that means
I see.
you should have higher value. But now watch this. If I compare, oh, now why did it not work? Really? What happened?
Yeah, I think that's
This was the same with
Yeah.
the compensation. Then we had one with the compensation off, which should be this one. Let's just try running it again. Let's run it again. Let's turn off the compensation.
So compensation means like it's a some parasitic effects.
Yeah.
And that's without compensation?
Yes.
5.2, okay. 10 minus 12.
Wow. Showing you the difference
See, this is 4.
between the two.
Yeah,
Yeah.
this is almost 10 orders of
Yeah. Okay.
magnitude.
So that's how much the compensation
Yeah.
has an effect on it.
That's
But
a huge.
yeah, but wow, it's so the scale is so weird. You're not seeing the
Yeah.
whole picture here. Unless we do that.
Because that is like 55 without, and then with compensation.
That doesn't seem. Let's see. Okay, the original one has got more capacitance. Huh. Okay, it's about the same scale, but I guess they're so far out. There's so much capacitance here that it's throwing off the graph.
Yeah.
That's what it is.
Wow, that's
That's a lot. That's a big difference between that and that. 55.9 and 5.2. Wow.
Yeah.
So there's a lot of capacitance. Most of it's probably coming from this guy. That's my guess. So if you take that out, you can get rid of that capacitance, but the compensation gets rid of it. So you shouldn't have to
Yeah.
worry about that. Every CV meter has a sweet spot. Ours is 1 megahertz. That's just where it works the best. And you're going to find that with any CV meter because they're not all going to work the same at different frequencies. Most of them, they run at 1 megahertz. Now we could change that, or we could do a frequency sweep. We could run capacity, but not on a MOSFET.
Yeah.
You're not going to do that, right? So
For a MOSCap,
MOSCap, you could do.
you can do a frequency
Yeah,
sweep.
you can do a frequency sweep. I don't have a MOSCap. So
If I were to do a frequency sweep on a MOSCap, how would I configure it? Here?
you have to go select the MOSCap test.
Oh, you have a MOSCap.
So you go to our devices, and you say MOSCap.
Oh, I see.
There it is. I say search. There it is, and you can drag that over here. Or no, you just say add. And it adds it right there. And then here's your figure. Does it give any data? No. Doesn't have it. You'd have to set this all up. Oh, this is there's nothing here, so this is not a good example. Let's see. Projects. I think there's a project for MOSCaps, or just caps in general. MOS capacitor, here it is. Create. Place the existing plan. That's going to wipe this out. There it is. So there's your CV sweep. Let's see. So that's a single frequency, and that's what you get,
Yeah.
right? And this guy. I don't know what the blue is. Not sure what that is.
And the MOS and PMOS, right?
No, that's
MOS is this.
That's some calculated, let's see, there's something there, I don't know what that is. That's here, it tells you here. Inverse squared capacitance as a function of the gate voltage. It's 1 over C squared.
Oh, okay.
Yeah,
So it is a straight line.
right. You get doping profiles. I've never used these tests, so I don't know a lot about them. But it tells you, you know, about the test right here. So
Okay.
it even gives you links to application notes that could help you,
Mm-hmm.
stuff like that. Okay. Okay. So that's basically my demo.
Okay.